This is the pre-mesh, the first mesh. So there are some improvements which we can do here. So first of all, we know that this is a triangular, a wedge-shaped block, and we know that this quality will be bad here because of the edge concentration here. So we can improve this block and all the triangular blocks by going for a quarter O grid in these. So let's go here, and I go to quarter O grid. Let me switch off the pre-mesh. Then I select this block, this thin block here, the wing, triangular thin, and here. So all the 4 triangles I have selected, triangular blocks, and I am converting them to Y block to improve the mesh there. Then I select the mesh. So I need to reassign the parameters. Say 4 here. Mesh. So the edge parameters have been reassigned here, and we are looking at a better quality mesh compared to what was initially. We can improve the mesh a little more by changing the distribution on these, make it a little more finer to match with the now the mesh looks better. So this is our mesh of the rocket. This is the mesh of the rocket, and we can switch on the mesh of the fluid domain as well. Let's see how does it look. The fluid domain looks little bit not so symmetric. It's very fine near the wings and not so fine away from it. So this is the we can assign edge parameters on this edge, say 12, and here say 8. So the mesh looks much more evenly spaced out. I can do one more thing. I can improve the distribution here. I can go for linked I can do a linked edge here, and I can go for so the mesh distribution becomes a little more smoother. Similarly, I can do a linked on this side as well. For linking to take place, the two edges should have the same vertex. They should match the same, match at the vertex. So the mesh gradually spreads compared to what was done earlier. Similarly, we can do a so the so what I have done is nothing but to improve the mesh transition by linking the two edges at which meet at the same vertex. Seems that the mesh is a little bit much fine here, and we can improve that as well. Improve that by making it say 6. So this is the final mesh which we have got. Before I close this video lecture, I can do one more thing which will improve the quality of the mesh. We have merged the vertices here to take care of the shape of the wing. We can merge the vertices on the surface of the tunnel as well to improve the quality of the mesh. Let's do that. So we will merge the vertex, say here and here, say apply. Then I can also merge here and here. Say apply. So the mesh becomes a little more symmetric. You can do that on the other side as well. So we have made the mesh symmetric on these two ends. Do it on the top here as well. What we are doing is that we had initially merged the vertices to take care of the shape of the wing. We are merging the vertices, the corresponding vertices on the tunnel surface as well, so that the mesh becomes uh, more, the quality improves. and then similarly on the other end. So on the four tunnel walls, I have merged these two meshes, these two nodes to improve the quality. This was because of the wing being triangular in shape, while the mesh is, as you know, rectangular. So on all the four walls, I have done the merging to improve the quality of the mesh. So now we can launch one more pre-mesh. So this is how the mesh looks like. Now we can, of course, we can play with the mesh distributions and keep improving the quality. So this is with this I close this video lecture. We have the mesh of the rocket here. This is the mesh of the rocket. This is in the solid domain, and the rocket here, and we have the mesh of the fluid surrounding the rocket. So that's the end of this video lecture. Thank you.